Okay, so hello. Today we're doing the lab, the lab, the static analysis lab. Basically, what we're doing is we're using the static application security testing um, to evaluate some vulnerabilities on different files. So for this, we're gonna use the software or the application called semgrep. So first of all, we need to install it. So for that, we're gonna first update the libraries, making sure we're in the last for everything. So we have the latest packages, we have everything updated, and after this we're gonna install the Python 3 because that's the installer we're gonna use for the same grep. So we're gonna say sudo apt install python 3 python 3 pip dash y. Okay, so normally it takes longer than this, but the problem was that I have it installed already because of practice try I did before, so that's why. So next, after this, we're gonna install the semgrep. So for this, we're saying pip3 install semgrep. All this is running, and after the installation is done, we can check if the semgrep has been, it's been installed by checking the version, and we can see it. Effectively, we have it. It's right here. It says we have the version 1.100.0. So with this, we can start working in the lab. We can actually start doing the lab. So first, we need to get the files that we're gonna scan. With this, we're gonna clone the directory from the GitHub account. So we're gonna use git clone https dash dash github.com dash k aparts gc dash sc 411 lab oops dot git. So if I did everything correctly and we look on the there we go, there is the library that we're looking for right here. So what we're gonna do now, and the reason and because we need to start the analysis already, we're gonna move to this directory. So that's pretty easy. So cd cy. Once we move, we can see everything that is in here. Um, Especially the ones that will have the vulnerability on. I mean that directory that has the vulnerability on. Is this directory src? So for example, if we scan right now only for JavaScript, oops, JavaScript, and we're gonna ask to to export all the results in a file called report. We do this, that's what we're getting. So basically, it's scanning 8 files, and it's gonna scan 2 files with 69 JavaScript rules because we told it only to scan using JavaScript rules. And in those 2 files, um, SemGrade was able to find 11 vulnerabilities. But even if JavaScript is actually really good, SemGrade has several others configurations that supports another languages. For example, a significant one that including security checks is the OWASP top 10. So why don't we do an scan it with that? So we're gonna say semgrep config or configuration equal https semgrep.debye obosp then, and we're gonna do the same. We're gonna ask to send everything to report obosp.txt. Just give it a minute. It's loading. Perfect. Okay. So first difference we can see is the quantity of files. Um, in this case, look, we have before there was only 8 files tracked by 75 code rules by GIT. Now we have 9, only 1 file more. But look at the code rules. There are 534 against the 75, and it gives us the different files that we're scanning. For example, you have multi languages. There were only 6 rules and 9 files. Then we have JavaScript, 2 files, JSON, 2 files, different rules. And here we can see it says we run 75 rules on 9 files. And again, we find 11 vulnerabilities. So what we can do now is what are these vulnerabilities, right? Because we need to see them to and actually to take care of them. So we can go to report. Oh, actually, it's report. Oh, it's txt. There we go. Okay, and here we have a list for all the vulnerabilities that the scanning found. So just to give an example, we have this one. This is the first vulnerability. Oh, something interesting is that how do you know which file has the vulnerability? It's you have it right here, and as I said, it's on the source file and is the app2.gs file. So as soon as we go through maybe like 2 or 3 vulnerabilities, we're gonna go to this file and we're gonna solve the 11 vulnerabilities, and I'm gonna explain a little bit about that too. But for example, the first one says don't use the default session cookie name. Using the default session cookie name can open your app to attacks. The security issue posted is similar to X powered by a potential attacker can use it to fingerprint the server and target attacks accordingly. So basically, it's telling us that we need to create a name for the cookies we're using. We can't use a default name because it may create a vulnerability. Another different is this one, for example. A hard-coded credential was detected. It is not recommended to store credentials in secure in source code, as this risk secrets being leaked and used by either an internal or external malicious adversary. It is recommended to use environmental variables to securely provide credentials or retrieve credentials from a secure vault or HSM. And this is something interesting about the semgrep analysis is that it doesn't just give you a this is the problem that it does, but it also gives you an idea of what you can do to solve this problem, right? Something similar to that happens here. For example, this is a vulnerability for an SQL injection. It says detected user input used to manually construct a SQL string. This is usually bad practice because manual constructions could accidentally result in a SQL injection. An attacker could use an SQL injection to steal or modify content on databases. Sorry, and this is the part. Instead of parameterized keyword, which is available by default in most databases engines, alternatively, consider using an object relational mapper, OR, ORM, such as Sigilize, which will protect your queries. And if you want more information, I also give you a link that you can go and check. But this is the one that is interesting about this. It doesn't. It check for many vulnerabilities, many rules, and it tells you like, hey, you can do this. You can do this to fix it, right? So knowing this, we are gonna we're gonna check like what's how can we solve all this. So for that, we're gonna go and start working on the vulnerabilities. So again, as I said, since we export everything into this file, we have it right here, but we're interested to go in here because as we remember, all the vulnerabilities were found in the app2 .gs file. So we're gonna say cd src and beam app2.es, and here we have it. This is the code that is creating all the problems. So let's start with the first one. Okay, so jumping to the first problem. The first problem is the cookie name. Basically, the problem is that we use the default session cookie name, and this can be a problem because it's a really predictable name. It uses the name connect that as ID. It's something that is predictable, so you know an attacker can just um, can easy identify it and maybe use it to fingerprint our application. So the best we can do is change the cookie name to something unique that can help us to protect against this kind of problems. And it's something that I did already right here. It's pretty easy. All we need to do is we need to add um, this part, the name part. We need to say name and select like a unique name for the vulnerability. I mean, sorry, a unique name for the cookie session. Okay, it can be any name, but I choose this one since it's a CYSE 411 at lab. But that's pretty much it. That's how we solve it. Um, then the next one is gonna be missing the domain name. In this issue, in this second vulnerability, highlights that the session middleware is not explicitly setting the domain attribute for the session cookie. The session attribute determines the cookie's scope and which domains can access it. Without specifying a domain, the session cookie is only available to the exact domain that is issued, or by default, basically. And this can sometimes be insecure if it's not properly managed in scenarios like subdomains. So basically what it's saying that without an explicit domain, the session cookie is only available for the exact domain the that is issued. This can be really risky, and as I was saying, especially for subdomains. And the solution is pretty easy. It's pretty simple. We just need to explicitly set the domain attribute in the session configurations. Basically, what we're saying is this part. In the original file, all this part was missing, everything. But again, it's not something hard. You just need to type cookie and then start doing all these configurations, all these parameters. Like the domain, you can put example.com, like in my case. But if you're hosting or it's like a host case, you can actually delete all that and leave it blank. Is something that you can decide about that. And I also add a couple things like the path, the max age, which is the expiration time, the HTTP only, and the secure. And I add these because there are some vulnerabilities that talks about that, but we're gonna go through that in more detail later. So moving to vulnerability number 3. Oh, and look, this is the part of the expiration time. So this issue points out that the expiration attribute for the session cookie is not set. The expires attribute controls when the session cookie should expire and be removed from the client. Now, um, without an expiration date, the session cookie is treated like that as a session cookie, which is deleted when the browser is closed. So, for better security and control purposes, it is a good practice to define an expiration time for the session cookies. It may not be like the most riskiest vulnerability ever, but it's good practice just to give it a time, and that's what we did in here. Oh, this actually like this if I'm okay. That we're basically setting this at 24 hours. That the cookie is gonna expire in 24 hours. The good thing is that this ensures that the session doesn't remain open indefinitely. Which can help to mitigate session hijacking risks. So with this, we can jump to vulnerability number 4, which is the HTTP only not set. Um, this is a warning basically, and this indicates that the HTTP only attribute for the session cookie is not set. The HTTP only flag prevents cookies from being accessed via client-side JavaScript, which which helps mitigate cross-site scripting attacks. Basically, with the HTTP only, the cookie is inaccessible to JavaScript running on the client, ensuring that even if XSS occurs, the session cookie is protected from being stolen. And again, all this part was missing in the original script. I add all this. I add this part. So again, it's a simple solution. We just need to type on the configurations of the cookie, the HTTP only, and we need to make it through to actually make it work. So with that, we can jump to problem number 5, which is the path problem, this one. And again, I fixed it already, but the warning highlights that the path attribute for the session cookie is not set. The path attribute controls the URL path where the cookie will be sent. If if not set, the default is just this one, meaning the cookie is sent to for all the path in the domain. By default, the cookie is sent to all the path in the domain. However, in some cases, we may want to restrict the cookie to a specific path. And why is this a problem? Well, this is not a critical issue, but setting a specific path can limit the cookie's scope, which help manage session cookies more securely in multiple path application. It's basically like when you have multiple paths, it's better just to keep it on one so you don't see your cooking like traveling in many different locations. But again, it's something that we solved already. I put this one because it's the default. But you know, so like you can actually put any other path in your domain that you want to your cookie to be specific on. Then for vulnerability number 6, it's about the secure attribute. The warning indicates that the secure attribute for the session cookie is not set. The secure flag ensures that the session cookie is only transmitted over HTTPS. protecting it from being exposed over insecure HTTP connections. And again, this is something really easy to do. We just need to set secure and then true. That's all we need to do. But the good thing about this is that as I was reading, the this ensures that the session cookie is only transmitted over HTTPS, which is way more secure than HTTP. It's basically like adding an extra layer of protection against problems, against attacks like the man in the middle attack, for example. Okay, so moving to the next one, which is the hardcore credential problems, issue number 7. So this warning indicates that the source code has detected a hard-coded secret. In this case, the secret used for session management, which was right here. Before it was something like this. Let me do it really quick. Before it was saying something like secret, so you guys can my secret come. This is how it was before. And again, the problems are solved already because I did the lab before already, but I'm gonna try to explain the best I can. Um, but yeah, basically it was like this. That's why the hardcode credential came up. So basically, hardcoding secrets, well, showing hardcoding secrets directly into your source code or having it in our source code is considered a security risk because it exposes the secret to anyone who has access to the source code. Basically, for A or B reason, somebody has access to the code and you have a secret here, or where hard coding secrets, whoever has access on it is gonna be able to see it. So it's recommended, or well, it's a simple solution to store the secret in an environment variable. For example, it could be in .env file. That could be the quickest solution. And for that, we just need to change the code from this. We need to delete all this and type this one, which is process.env.session secret. Basically, is that whenever this loads, it's gonna load the secret from the environment variables, and it's gonna load it here in this code. And if you're wondering how do we create the .env file, this is how we do it. We set .env file, then session secret, which is the name of the file, then you put your secret, any secret you want. Then next, for issue number 8, we have the tainted code. Basically, in this case, user input like username and password is directly inserted into a SQL query, making it vulnerable to injection attacks. Basically, is that we're allowing them to put a code in the system so that as an input they can give us like an SQL code, potentially giving them access to modify sensitive data in the database. So the vulnerability was here, and the problem is before it was like this. And the password was the same problem, was the same thing. And again, this is incorrect, mostly because any input you put for the username is gonna treat it as a part of the SQL query, and it's gonna treat it as a code. If they treat it as a code, um, whatever code they put, it could be like a malicious code. We're gonna compromise our database. So that's why this is not correct, or this can be considered a vulnerability. So what we do is we delete this part. We replace it only for the interrogation sign. This is basically called um, parameterized queries. We're doing this to safely handle the user input. This simple change automatically escapes special characters and prevent malicious input from altering the query. Okay, so it's not something really hard. So it's important just to leave it with it like this. So if we move to number 9, is the XSS vulnerability. So this happens when user input is injected directly into HTML without proper sanitation, which could allow an attacker to run a malicious JavaScript, or basically a cross-site scripting attack. And that problem was right here. The problem here is that before it was something like this. So it's sent like this. H1 welcome, and username. It was something like that. Now, what's the problem with this is that this allows whoever. Yeah, so basically what we're saying is that in this with this code, or the way that it was before, um, we create a vulnerability, and is that it directly injects unescaped user input into the HTML response, making it accessible for the cross-site scripting, as I was saying. Basically, if an attacker submits a script, something similar to this, it could execute malicious code in the user's browser, potentially stealing cookies, session tokens, or performing actions or on behalf of the user. So the way to solve this was by changing it to this function. And we did this. Oh, actually, now that I'm looking at it, this is wrong. It's supposed to be something like this. Let's see. It's gonna be welcome here. Okay, it's gonna be something like that. Okay. Basically, what we're doing here is that this function is um, templating. It automatically escapes user input, preventing the injection of malicious code. So the good thing is this one use an engine called EJS, and this is the one that is showing the templating. Okay, so that's something good. And with this, we can jump to issue number 10, which is another one, HTML injection, but it wasn't the same problem. So by the time that we fixed it, we fixed the problem number 10. It was another cross-site scripting problem, so should be good. And now for the last part, we're encountering a raw HTML injection, or basically it's another SQL query injection, and that was located on this site right here. Before, it was something like this. Whoop, whoop. Same as before, and I already explained why this is wrong. Again, any input that they put is gonna take it as a part of the SQL query, and it's gonna run it as a code there. It's compromising our database. So the best we can do is the same parameterize it and just put an interrogation no. Okay, but it was the same problem as before. The same problem as we got in here. That's why I'm not going too deep into it. And with that, we should solve everything actually. Let me see. For example, just to show, I went back to the old file, to the original one, and I'd run the scan again. And look, before from the 11 findings we got, we have only one right now. It's probably something that we did wrong on the code or something, or something that we may check. Something I'm gonna check probably after I finish the video. But thank you so much for watching, and hope this is good.